36,000 feet down, there is no light, no rescue, only pressure and mouths. The ocean has 5 levels. Each one takes something away from you, and the creatures that live at each depth are built for conditions that would kill everything above them. By the end of this video, you'll understand every layer, what survives there, and why the animals get more disturbing the deeper we go. Let's descend. Zone overview. The ocean is divided into 5 pelagic zones, each defined by depth, light, pressure, and temperature. Sunlight zone, 0 to 656 feet. Twilight zone, 656 to 3,300 feet. Midnight zone, 3,300 to 13,123 feet. The abyss, 13,123 to 19,685 feet. The Hadal zone, 19,685 feet to roughly 36,089 feet. These are not gradual transitions. They are thresholds. Cross one and the physics change. The chemistry changes, and the survival strategies change with them. The sunlight zone, 0 to 656 feet. This is the only layer where sunlight drives the food chain. Photoplankton convert light into energy. Zooplankton eat the photoplankton. Small fish eat the zooplankton, and the chain builds until you reach whales. 100% of the ocean's photosynthesis happens here. Because energy is abundant, so is speed, color, and open confrontation. This zone contains more biomass than every other zone combined. It is also the only zone where human vision works as intended. You can see what is hunting you. That changes soon. Great white shark. Great whites do not rely on vision for their final strike. Along the snout are tiny pores called ampullae of Lorenzini, organs that detect the faint electrical fields generated by muscle contractions and nerve impulses. In the last moments of an attack, the shark is reading bioelectricity. It doesn't need to see the target. It feels it first. Some leave coastal waters entirely and travel to a mid-Pacific region nicknamed the White Shark Cafe. Satellite trackers show repeated bounce dives, deep and then shallow, as if the shark is scanning different temperature layers. The full purpose is being studied. Short fin mako. If the great white is a sensor platform, the short fin mako is raw acceleration. Burst speeds documented up to 46 miles per hour. Hydrodynamic body, explosive tail. One hunting strategy, close the distance before the prey reacts. In open water with no structure to hide behind, speed is the only advantage that matters. Manta ray. Oceanic mantas can span over 20 feet wingtip to wingtip. They look like apex predators. They are filter feeders, a creature wider than a car, powered by prey smaller than a grain of rice. And they are among the few fish species to pass the mirror self-recognition test, suggesting a level of self-awareness rarely documented in marine animals. Bait ball. A bait ball is not one organism, it is a collective defense response. Thousands of sardines compress into a tight rotating sphere that confuses predators trying to isolate a single target. But when dolphins, sharks, and diving seabirds attack from multiple angles simultaneously, the ball fractures. And once it breaks, the individuals inside have nothing left. Below this point, the water turns cobalt, visibility drops, and the ocean begins operating on a different set of rules. The twilight zone, 656 to 3,300 feet. At 656 feet, sunlight drops below 1% of surface intensity. By 3,300 feet, it is gone entirely. Plants cannot survive here, so the food web depends on 2 things: whatever drifts down from above and whatever is willing to travel upward to eat and then retreat back into darkness. That retreat triggers the largest daily migration of biomass on Earth. And most humans have no idea it is happening beneath them. Every night, billions of organisms rise from the twilight zone toward the surface to feed under cover of darkness. Every morning, they sink back down. It is called diel vertical migration, the largest synchronized animal migration on the planet. And it happens every single night. So, what does a food chain look like when the sun is no longer part of it? Bristlemouth. The bristlemouth may be the most abundant vertebrate on Earth. Estimates suggest populations in the hundreds of trillions to quadrillions, roughly 1 to 3 inches long, with rows of bristle-like teeth and bioluminescent photophores along their undersides. Despite those numbers, most people have never heard of them. They live too deep and die too quickly at the surface. But in the twilight zone, there are dominant vertebrate, an entire kingdom of life that most humans will never see. Barrel eye fish. The barrel eye has a transparent, fluid-filled dome over its head. Inside that dome, 2 barrel-shaped eyes point straight upward, scanning for silhouettes of prey or predators above. When it spots food, those eyes rotate forward to track the target. Evolution built a glass cockpit around the most critical organ this fish has. Because down here, detecting a shadow 1 second sooner is the difference between eating and being eaten. Vampire squid. The name suggests a predator. It is not one. The vampire squid lives in oxygen minimum zones, layers where dissolved oxygen drops so low that most complex animals cannot function. Rather than hunting, it extends thin filaments into the water and collects marine snow, the slow rain of dead organic matter from above. A deep-sea creature surviving on the debris of the world above it. At this depth, speed is a liability, stillness is strategy, and the creatures that dominate are the ones that waste the least. But the next zone does not reward patience. It rewards weaponry. The midnight zone, 3,300 to 13,123 feet. Below 3,300 feet, sunlight is gone. Not dim, gone. If your flashlight fails here, light does not get low. It stops existing. The only illumination comes from the organisms themselves, cold flashes of blue and green in a permanent void. The economics of this zone are brutal. Find food, avoid becoming food, spend as little energy as possible doing either. So what does a predator look like when it has to build its own light to hunt? Anglerfish. The anglerfish carries a modified dorsal spine that functions as a fishing rod. At its tip, bioluminescent bacteria produce a glow. In total darkness, that faint light is the only point of interest for miles. Prey approaches. The mouth does the rest. But the anglerfish's strangest adaptation is reproductive. In some species, males are a fraction of the female size. When a male finds a female, he bites into her body and fuses. His circulatory system merges with hers. Over time, he becomes a permanent parasitic appendage. In an environment where finding a mate may be a once-in-a-lifetime event, evolution solved the problem by making separation impossible. Gulper eel. The gulper eel is essentially a mouth with a tail attached. Its jaws can open wide enough to engulf prey larger than its own body. At the tip of its whip-like tail, a bioluminescent organ glows, possibly functioning as a lure. In a zone where meals may come weeks apart, the gulper eel is built around one principle: do not miss. This next creature has never been filmed alive in a natural hunt, but we know the fights happen. Giant squid. Sperm whales surface bearing circular scars from giant squid suction cups, each cup lined with sharp, tooth-like rings. Some whales dive beyond 7,000 feet. Somewhere in that black water, predator meets predator. The evidence is written on the skin of every whale that comes back up. Giant squid can reach lengths up to around 43 feet, with the largest eyes in the animal kingdom up to 10 inches across. One theory suggests those eyes are suited to detect approaching sperm whales by reading the faint glow of bioluminescent plankton disturbed in the whale's wake. They are not mythological. They are measured, documented, and scarred into the bodies of the animals that hunt them. Viperfish. Viperfish teeth are so long they cannot close their mouths. The fangs curve back over the head like needles in a trap. Along its body, photophores produce light. Some lure prey, some erase the viperfish's own silhouette, a technique called counter-illumination. Predators below look up for dark shapes. The viperfish matches the ambient glow from below. It becomes invisible by glowing. We are still thousands of feet from the bottom, and the next zone does not reward hunting, it rewards waiting. The abyss, 13,123 to 19,685 feet. At 13,123 feet, you reach the abyssal plain. Vast, flat, and still. Pressure exceeds 400 atmospheres. Temperature hovers near freezing. The only food supply is marine snow, dead plankton, fecal pellets, and organic fragments that can take months to reach the bottom. When something larger falls, a whale carcass, a chunk of driftwood, the seafloor wakes up, scavengers arrive, they feed, and then they wait again. Imagine months between meals. This is the rhythm of the abyss. Giant isopod. Giant isopods look like something prehistoric, armored, segmented, roughly the size of a football. In captivity, specimens have survived years without eating. When food arrives, they gorge. Their biology is not designed around starvation, it is designed around uncertainty. Dumbo octopus. Dumbo octopuses use ear-like fins to move through near-freezing water. No ink defense, no jet propulsion, just slow, deliberate movement above the sediment, searching for worms and small crustaceans. In a zone defined by efficiency and threat, the Dumbo octopus drifts like something that wandered in from a different ocean. Tripod fish. The tripod fish does not swim to hunt, it stands. Using elongated fin rays, it plants itself on the seafloor like a tripod, faces into the current, and extends its pectoral fins forward. Then, it waits. In the abyss, chasing food costs more energy than the food is worth, so the tripod fish turned patience into a body plan. If the creatures here look alien, the next zone makes them look normal. Because past 19,685 feet, vertebrates start running out of physics. The Hadal zone, 19,685 to 36,089 feet. Below 19,685 feet, the ocean enters the Hadal zone, named after Hades, the Greek underworld. This is not a continuous layer. It exists only inside trenches, deep cuts in the crust where tectonic plates collide and one is forced beneath the other. There are 46 known Hadal trenches. The deepest is the Mariana Trench. Its lowest point, Challenger Deep, drops roughly 36,000 feet, about 10,935 meters. The pressure here exceeds 1,000 atmospheres, over 16,000 pounds per square inch. Imagine 4 pickup trucks balanced on your thumbnail. That is the force pressing on every square inch of surface down here. And yet, life persists, not in familiar forms, in forms that suggest biology has been rewritten from the cellular level up. This next creature is the deepest fish ever filmed. Hadal snailfish. In 2022, researchers in the Izu Ogasawara Trench off Japan recorded a juvenile snailfish at approximately 27,349 feet. Pale, translucent, no scales, no swim bladder. Its skeleton was largely cartilage. Its skull had gaps that never closed, because at this depth, rigid bone is a structural liability. Flexible tissue survives. At this depth, even proteins would collapse. So Hadal snailfish lace their cells with TMAO, a chemical brace that keeps life from crumpling under 1,000 atmospheres. Research suggests there's a hard boundary for fish somewhere between 27,000 and 28,000 feet. Below that, vertebrate biology reaches its limit. The trenches beyond belong to invertebrates. This next creature builds armor out of the trench itself. Hirandalia gigas. When anything organic falls into the Hadal Trench, amphipods arrive. These shrimp-like crustaceans swarm bait on trench landers within hours, pale and frantic, stripping a carcass to nothing. Researchers have found their exoskeletons coated in aluminum hydroxide gel, a compound derived from sediment minerals. Their armor comes from the trench floor. They've integrated the geology into their biology. Xenophyophores. They look like clumps of sediment of strange mineral formations on the trench floor. But they are alive. Single-celled organisms, giant foraminifera, that build trenches from minerals and biological debris. One cell, a visible architecture. Some specimens reach several inches across. A human red blood cell is about 8 micrometers wide. A xenophyophore can be 10 centimeters. Same cellular blueprint, scaled up by a factor of roughly 12,000. They are not animals, not plants. They are protists that build at a scale that makes the word single-celled feel like a mistake. And in some trench regions, life is not even waiting for food to fall from above. Chemosynthetic communities use chemical energy from the seafloor itself, hydrogen sulfide and methane seeping from tectonic activity, to power entire ecosystems. No sunlight, no connection to the surface world, a completely independent food web running on geology. We have mapped the surface of Mars in higher resolution than the bottom of our own ocean. Less than 1% of Hadal trenches have been visually surveyed. Scientists estimate thousands of species remain undocumented in those trenches alone. So when you see footage from the deep and sometimes feel wrong about what you're looking at, you're not being irrational. You are seeing what evolution produces when it operates without light, without warmth, and without the structural rules that govern every ecosystem you have ever known. The ocean does not need mythology to unsettle it. It just needs depth. And somewhere in the 99% we have not surveyed, something is waiting to be filmed for the first time. If you want to explore more of the Hadal Zone, check out our video on the Mariana Trench on the screen now. Subscribe to Below the Blue. See you in the deep.